Hi everyone, welcome to another video. Today we'll be solving the question of merging two sorted lists. So here we are given this problem where we have two singly linked lists, list 1 and list 2, and both of them are sorted, and we have to merge both of them and return a final linked list. So basically for the first example, we are given these two linked lists and we have to merge them, and the final linked list should also be in sorted order, and we have to splice the list together. Basically we have to move the pointers and not make brand new linked list nodes, and we have to return the head of the merge linked list. So the way we are going to solve this problem is by using a dummy node. So using dummy node, we will create a fresh list and we're going to merge list 1 and list 2 nodes into this fresh list depending on the logic. So let's create a dummy node first. So here I have new list node and let's assign it value -1, and at the end we have to return dummy.next. So let me also define two pointers which are going to iterate over the two lists, p2 list 2, and for iterating over the linked lists we can use a while loop. So initially we have to iterate over both of them together, so that is why in the while check I have both of them. So if both of them are not null, what I can do is I can check if p1.val is less than p2.val, and I can have an else check. So for the case when p1.val is less than p2.val, then I'll move the node from list 1 into my final linked list. So for the final linked list, I also have to create another variable and assign it to dummy, and this way I can set current.next equal to p1 or p2 depending which one is less. And this else case will also have the case when p1.val can be equal to p2.val. So for that we can just merge the node from list 2 into our new linked list, or we can do it either way as well, it doesn't matter. So for our if check, what we can do is we can set current.next equal to p1, and then we can move our p1 pointer to the next node. And for our else check, we can set current.next equal to p2 and move our p2. And for both of them we have to move the current pointer forward as well, so I can do it here outside of if and else blocks. And once I'm done iterating over both of them together, so what could happen is either p1 can be not null, or p2 can be not null, or both of them can be null. So for that case, if p1 is not null, then I can set my current.next equal to p1, and if p1 is null, then I can set current.next equal to p2. So what I can do is do this, and I can set current.next equal to, so if p1 is not equal to null, I can set it to p1, else I can set it to p2. So here I just use ternary operator, and at the end, as you know, we have to return dummy.next. So let's try to run it, and that works, which is good. And let's try to submit, and that works as well. So this approach used dummy nodes, and here the time complexity is O of n, where n is total number of nodes from the list 1 and list 2, or if you want to have like length for list 1 as m and list 2 as n, then it would be O of m plus n, and we can just simply set m plus n equal to bigger n, and it would be simply O of n. And space complexity is constant because we did not create any brand new nodes other than dummy node, which is just one node, which is uses constant, which is just constant space. So this was the optimal approach for this problem. And another approach we can use is, if we don't want to use dummy nodes, what we can do is we can merge either list into another list. For example, we can merge list 1 into list 2 or list 2 into list 1. So we can pick one list and pick another list, and we have to decide which list to merge in which one. And this would just have a little bit complicated if checks. So using dummy nodes is quite simpler, and I'll explain in a separate video like why using dummy nodes is helpful for linked list problems. So I hope the solution made sense, and I'll see you in the next video where I will be solving the question of merging k-sorted linked lists using divide and conquer. So thank you for watching, and I'll see you in the next one.